I would like to introduce first speaker, Satoshi Tadokoro. Is a professor of Graduate School of Information Sciences and the International Research Institute of Disaster Science, Tohoku University. Welcome.
Thank you for your kind introduction. Good morning, everyone. I'm really happy to be here to give my talk because I'm living. So it is really amazing we have so many disasters in the world. And so we have big earthquake very frequently. And in these 10 years, 1 million people died by that disaster. And for the people affected, the number is much larger. 4 billion people are affected. So we have to think of the disaster more carefully. I experienced the Hanshin-Aji earthquake in Kobe in 1995. At that time, a student of mine buried more than 4 hours in debris. Professor Matsuno's students died, and yes, so serious. But I found we have no robots, no intelligent system, no technology which were effective for this disaster. We had to do that, we had to start something from the scratch, from the grassroots. That was what I thought at that time. And yes, we started with our colleagues, our friends, and we made a big effort to create something from that time. One of the largest efforts was RoboCup rescue. I really thank Hiroaki, Minoru, and Manuela, maybe here, I don't know. Yes, they supported the starting RoboCup rescue very much. And we did 2 things. One is a simulator, and second is a real robots. As for the simulator, we create the Omniverse, and the agent works, first responder agent work in the Omniverse. And yes, we started the competitions. This was our roadmap as a dream. We had a dream that contribution in real disaster field in 2020, and mighty rescue robots in practice in 2050. That was our roadmap and dream. Yes, I don't know what is the 2050, but I love this type of the manga animation very much in my childhood. But anyway, we have to have some solutions to help human in the case of such kind of big disaster. So from the scratch, we started. So at the beginning, the robots were really a toy type. However, as time passes, the technology was developed, autonomy or mobility, sensing or SLAM, or yes, several technologies contributed to this effort. And this is an example. This Kenaf had a really high mobility in this rough terrain. And yeah, it shows very nice capabilities. And we tested this creature with a first responder in the training site, Disaster City. And yes, they said, maybe we can use it. And yes, several the national projects or international projects run, and this is one of them. And this DDT project researched the snake robots, UGV, UAV, balloon, IoT devices, and so on. Yeah, so it was so fantastic research effort, and we could make something for the future. This is one of the examples that I made it. I was a researcher in, this is an active scope camera for search in rubble pile, 3-meter gap, 10-meter deep. And I was a researcher in the domain of the actuator or soft robotics at that time. So I applied our technology to achieve some mobility in the rubble pile. It was a really tough things. However, we found this serially drive, distributed drive system is really effective because it was surrounded by the debris, and it must be robust if it is a really cluttered situations. So as a conventional research, we made a model, we made a simulation, and we made several experiments to optimize the design of this creature. Yeah, this was a really nice or really interesting scientific research for us. And as a result, we had a better performance than ever. So the yes, active scope camera could go into the really narrow space in 10-meter deep. So it was a nice achievement. And we asked the first responder to test it in disaster city, and their evaluation was so-so. Yeah, but from the starting point, as a starting point, it was really nice. I thought so. And after 10 years, this earthquake happened in 2011. Yeah, it was so serious situation. And Fukushima Daiichi was, as you know, so serious situations at that time. And we developed, by the collaboration of the RoboCup, and we made this robot Queens, UGV. And fortunately, it could be used as the first national robot in the nuclear reactor buildings to survey the radiation level and also the dust sampling and capture image and so on. So I was really happy that I could contribute to the cool shutdown of the nuclear reactors. And this is another unit of Fukushima Daiichi. The roof structures collapsed by explosion. And people needed to know the situation inside the narrow space. So we applied the active scope camera in this domain by some remodeling with Shimizu construction company. And yes, it was so successful, we could capture image like this or measure the radiation. It was so serious situations, but I was happy to be able to contribute to this effort. This is another research. The drone is really amazing invention, and it is so effective in every disasters. However, the problem is, I think the drone port. So at the landing, in usual landing port, the drone becomes very unstable because the power becomes lower, and also the degree of freedom is not insufficient. It's insufficient. So because of that, it is very difficult in high speed, strong wind. We cannot operate the drones. So we invented the horizontal landing system, and we call it Eagle Sport. And as you see, it can land under the high speed, it's very stably in comparison with the conventional drone port. And also, in one port, multiple drones can land. So it is, as a space, it is so efficient. And this is experimental result in the wind tunnel. And apparently, in the high-speed wind of 8 meters per second, it is at the limit of this small-sized drone. The landing time was 35% shorter. And yeah, it's a really nice invention. And I hope it be applied to the real disasters. Yes, we can make it this type of that. Then we can drive to the disaster site and open the hatch. And immediately after that, the drone can take off and then return to the station very easily. And so it's a very nice way of the operation. So at the same time, we have to think of the user side. So who are the user? Maybe the United Nations, OCHA, and INSARAC are the very top-level, high-level users. And INSARAC defined the guideline of the such kind of response missions. So this is an international standards for all the rescuers, first responder organizations. So that means the robots, rescue robots and drones are their tools under these guidelines. So we have to think of to follow this guideline, and we have to think of how our robots can be used in these situations. And this is an example of the disaster specialist research. So they are first responders. They think of how the structure as an architecture is made. And then they can know categorize the way of the collapse in some category. So they can use such kind of information for the real search and rescue. So they have statistical data and some mechanical analysis data, and then they can know how to reinforce the structure or how to approach in the narrow space or how to remove the debris. And if they ignore it, it is so dangerous situations. So I think I have to think the rescue robot intelligence in 2050 because we want to make good intelligence for this purpose. And the purpose of this robot is remote autonomy in inaccessible area. And inaccessible area means human cannot enter. So the higher onboard intelligence is needed, apparently. For example, the robots consider the nature of a situation scientifically. It is necessary. If you think of the way of the disaster scientists think, yes, it is necessary. And human is useless. Human cannot intervene appropriately. So we need such kind of intelligence as a robot intelligence. And secondly, robots work like top-class proficient first responders. Not only the movement, but also recognition, decision, and task execution. And they should be based on scientific analysis of disaster phenomena. I'm hoping this kind of intelligence can be achieved by 2050 as a dream. Thank you very much.
Thank you very much, Satoshi. And we would like to have questions from the floor. Any questions? Anyone? Okay.
Thank you very much for the nice talk. In your view, which are the main challenges to achieve the vision that you just presented by 2050?
Yes, so vision is a very important technology. So at present, we can recognize the material or some goods in debris. Yes, it is possible, but it is not the final goal. Imagine how the first responder recognizes inside the debris. So they think several things. For example, the structural, the structures, how the force is applied to the beams, and how it is unstable. Yeah, we have to know such kind of information. And also, if there's a gas, explosive gas, yeah, it sometimes happens, then we have to recognize that. Yeah, it's not a vision issue, but we have to know that. So imagine such kind of things in the real disasters by watching TV or anything. Then you will find good finding, good knowledge about that. And if you research into that, then it is a good solution for 2050, I believe.
So thank you again, and we'd like to give the hand claps. Thank you, Satoshi.